Welcome back to Mr. G's workshop, and just going through some more vise repairs and overhauls. This is the vise I've previously refurbished, and I'm quite happy with that one. Here we have a record vise, the 414 that I've bought, and I just thought I'd give it a check over. And this particular part looks a little bit unfinished, and also the could do with a little bit of a skim on the surface just to take the jaw float out, as this bit wants to move up just a little bit too much than I'd like. So I think I can improve on that. So I'll see how we go. So this is the other part that I should probably machine a new section that's slightly wider, so it fits this slot a little bit tighter, and also the fact we can pull that down to a much tighter clearance than we've got at the moment. Here's another vise that I've just reworked. This still got oil on it. It needs oiling up before I put it away, so I need to give it one final clean. But this was quite rusty, but it's not. If I open this up, we can see that it's had some service, because we can see where it's been bolted down on these slots. It's been bolted down at some point, but generally here the surface itself is okay. There's within the jaw there's a little bit of misalignment in the slots. Well, not misalignment, but it's where something's been tightened up that's not been too kind to the shape. But other than that, it's cleaned up okay. This was a very rusty vise, so I just need to give it a bit of an oil. But the thing I'm going to be focusing on in this video is the remachining of this part. I had to use a spanner to try and draw this bolt out, which was a surprise. I was expecting to see a thread in here, although when I inspected it I couldn't see anything. But when we actually look at it, there's no thread in there at all. But I had to use a wrench to get it out. But I think you can see there's a small burr in the bottom of my hole, so that's making it behave a little bit like a thread. You can see it a little bit better in there. So what we'll do is we'll make a new one of these, and then fit that in and see how we go. I've got to go through the process of making some dimensions for this, so I'll do that. So we'll make one the same as this, but with the changes that I've mentioned, of making this diameter a little bit wider so it fits the slot a little bit better, bearing in mind that this is a painted surface in here and not machined. So when we put this part in there, we don't want it too tight, because it'll rub on the paint high spots or the parts of the casting. So that's not a good thing. But I think we can do a better fit than that, which looks like it's to be around about 1/8 of an inch. Around about 1/8 of an inch there. The other thing that might be a select on test is when I've got the right size hole in there and the bolt drops in, is to tighten it up but make it to this dimension, and then think about trimming afterwards, so I can just skim some of the surface off just to make that fit a little bit tighter. But what I'll do is I'll make it exactly as is to start with, and then we'll do a little bit of fitting, although it's not ideal to take the part out of the lathe when you're finishing off these surfaces or turning these surfaces, because you end up with surfaces that aren't perfectly parallel. Here's the drawing I've come up with. This part is 1.5 inches in diameter, and I've gone into decimals here, so 0.556 on the shoulder here, 0.14 for the flange. That's 1 inch across, and our measurement is 1.09, so that's just under 1/10 of an inch, or 2.5 millimeters roughly to play with in terms of increasing this, in terms of improving its fit within the vise. Overall 0.696 of the height of the part, and looks like 1.5 inches, but that's actually a a 1/2 inch hole. Judging by the thread, I think we're looking at something that's a 1/2 inch Whitworth. Nice big chamfer on the inside edge there, but on the top edge that's quite a large lip, so that really could do with chamfering or deburring at least, just so that the bolt makes better contact with that, and maybe we'll make a washer, maybe a brass washer to go with that, just so that we don't gall the surface, because as I see the finish on this isn't fantastic for a machined part, even on the bits that don't see any action in the vise where they move up or they rub on a particular part of the vise. So I'll check through my stock now and see what material I can come up with, and then get the lathe loaded up, and I'll start machining the part. I've just been working through my stock, and I found this 1.5 inch piece of bright mild steel, so I'm going to go with using this. So as the diameter is diameter already, I should just give that a touch up with possibly Scotch-Brite or maybe emery, but we'll see how we go in the lathe with finishing this part. What we don't need to do is take a cut on it and reduce the diameter too much. So if we do a bit of polishing or final polishing or Scotch-Brite, emery tape, whatever the method, we're only going to be taking off a few thousandths. So with this part, I may cut this part in half so I can get it better supported in the lathe, and what I'm planning to do in terms of operations is to machine the part as we see it. So I shall face off on this surface, center drill it, pop the center in, and then machine this step up to this diameter, and then out, adding on the extra material that I want. So we'll be going for a larger diameter cut, and then I'll plan to run a parting tool in and separate the part off. Yeah, so I'll get this cut off and then set up in the lathe. The lathe, I've got the piece of bar in now, and plans are always changing. I've decided to, after centering it and the DTI on at this end, just to check that it's running as true as it can. As you see, the surface isn't perfect. I'm going to take away at this end, because this I'm going to machine away anyway, so it's going to save me another 1/4 inch of bar for maybe another project at another time. So I'm going to center drill this now, and then I'm going to put in a half center and support the piece, and then give that a run and see how we can go. So I want to try and face it off and get the step in. Now I'm keen to center drill it and get the center in at this stage while the part is concentric, because there is a risk that if I take a cut, being very, very careful just to put a skim on there and face that off, that I may move things under the load of the cut. So I want to get the center drill in first, and then I'll worry about facing off, and we'll see how we look. So I'm keen to be very efficient with the use of material, because it's very easy to just chop off bits of bar, and then you end up with lots of bar ends that are too small for well, almost anything. So there we go. as our pressure force is in this direction, there's not much chance of the piece moving off of line. So now we've got that drilled, we'll put in the half center, and then we'll start facing off where we need to, and then drilling the part down. So at the lathe now, I've got the half center set up, so I'm going to go in and face off where I need to, get to a 1/2 inch diameter, and then we'll start looking at turning down to diameter. I've just finished the facing cut on this surface. It's going to clear those out. You can see the advantage of using dead center is you can get right the way in, which you can't do with any other centers because you've got this clearance for the tool, which is most useful. I've only taken 1/10 of a millimeter cuts. This metric, this Myford lathe, being a metric version, is obviously we're working in metric. The other thing is, it being an old English machine, everything that isn't on the lead screws or adjusters in any way is an imperial thread. Okay, and I'll continue taking a few cuts, and I'll start taking the cuts down the side here so we can get to a point where we've got an even diameter. Then we'll look at setting the length and the inner diameter with spot marks, using this to give ourselves a guide so we can rough down quickly, and then when we get close to the target, then we'll start introducing the metrology side of things. So we'll have things like probably the vernier calipers in on this, and also we may use a depth gauge on this one, or maybe a ruler might be good enough. But I think we'll try and measure that when we get a little bit closer. I said I don't think there's maybe too much harm in turning this one too long, but I need to think about the processes ahead, because we have got a thin lip here. If I part the part, if I think that's going to be contentious, we've only got a thin lip there to hold the piece in place, so machining off after that may be difficult. The other thing would be to tap the inside, drill it out and tap it as a Whitworth thread, and put a bolt in there and use that as an arbor of some sort to support the piece. But that involves making another tool, and I don't see myself doing much more work in 1/2 inch Whitworth. But I may check the tooling drawers to see if there's anything in there that may be of use to help us get through this. So I'm now at the point where I've dressed this outer diameter so it's concentric. I don't think the bar was particularly round to start with, but we're running through now with this surface and this surface. So what I'm going to do is to use the tool to put a marker in here and determine where the diameter needs to be for my 1.09 plus a bit of clearance, and also for the depth from here to here. So I'll set the length from there using the tool as well. What I might do is touch off on this surface and then run down with the lead screw down to this point and put a mark in where the 0.556 line should be, which I will need to convert back to metric. So I'll be back when I've done that. At this point, I've put the chamfers on. I've put a light chamfer on this edge to stop any digging I think may occur. It may make things worse. Bit of an oversight on my part. Here's the original part. You can see the difference in the level of finish. I'm just going to go and saw this off after I've made a mark with the lathe, so I can bring it back and face it off. This is now drilled out to 1/2 inch, and our bolt fits in there okay. So that's what I'd expect. I don't know why the other one was an issue, but I think it's probably that burr on the inside face. Anyhow, I'll get this sawn off and then turn around into the chuck and then look at facing off and setting this distance here. I've just hacksawed the part off, and we've broken through the hole here, which is good, because by the time I machine that off, I expect we'll be up to diameter. And if we look at the part that I took that from, we can see there's just a small dimple from the drill. So I'm quite pleased at that we've used probably just about just a fraction over an inch of bar to make this piece. So I'll face this off and take it down to dimension on this lip now. As with every job, there's always a little surprise or a curved ball. Looking at this nut, there's actually a step in there that's greater than our ½ inch. So I've run a tap down there, a die down there to clean up the threads. There was some material in the threads that came out, so that's improved the threads. The threads look very good now, but we've got this increased diameter here, and I think that's what was holding this into the old part, is the fact that we've got something around about a 12.86mm diameter tightened down into a ½ inch hole, which is why it was difficult to get out. So what I'm going to do is I'm going to put a small relief in there. So I'm going to pop this in the lathe and put an eighth relief in there, just to take that under to diameter. It'll make for surprisingly a stronger bolt, but and also I'll be able to take that diameter down so it fits in my my reamed hole in the new part that I've made. Here's the original part with the surface as is, and you can catch that in the light. You can see it's got a bit of galling. There's this lovely lip on the edge that I think has been formed by the fact that the screw was jacked down into the part using the vise as a clamp. So we've actually pulled the bolt in and extruded the metal in that fashion. So it's not great. I'd be quite surprised if this was the original part. On the edge we've got the machining and the chamfer, and that's the machine surface. And if we put that into the vise, we've got quite a bit of slop. Here's our new part. It's quite a bit wider at the bottom end there. We're nearly 2 millimeters greater diameter. The top part is about ½ millimeter thicker, just to give it a bit more strength, and I've put a very artistic chamfer onto this one. If we offer that in now, we can see that there's a lot less play on it. I've still got to tighten this up so the proof is in the pudding, so to say. So I shall get that clamped up and see how it looks. Generally, I think it's looking okay. I'm just checking the fit of the vise in terms of side to side. For that part to line up, there's more play one way than there is the other, so that's kind of lined up there. So I couldn't really make that bush any tighter because the hole in the bottom of this part isn't drilled perfectly central, so it does allow me to line that up. If I'd gone tight, it would have sat like that. I might not have been too happy with that one. So one more thing just to check is the thickness of the gap, and to see how close we've got that. And there, that's 50 microns, and we're quite comfortably in there. Going to 10 now. Sorry, that's 100 microns, that was 50 microns. And we're just starting to pinch there ever so slightly at 10. I don't think the 15 will go based on that. And it doesn't too well, so we're just over the 0.1. So if I take off 0.5, I think that will get us exactly what we want. So we probably want to go a little bit lighter than that. Maybe a 0.03 or 04 maybe. But I'll give this a go, and we'll see where we are in a minute. I had an issue because we were closing up on the gap, and I was running the jaw backwards and forwards, and I found that the slot here, the thickness isn't parallel from one end to the other. So I've just put some parallels in under here and tightened it down onto the milling machine, and I've just given it a skim. Nice and easy because it's cast iron, so it doesn't need any lubrication. So that's gone well. What I'm going to do now is again is just check the clearance of the jaw between the bed, divide that by 2, and then skim that off on the lathe to see if I can get it close, because now I've skimmed a little bit off here. We're a little bit baggier than perhaps I'd like, and then there's a chance that the jaw will ride up when we tighten up, and I want to get that as good as I practically can. It's been some time since I've got back to this vise. The last thing we were doing was making a clamp for the underside, which I've now got fitted, and I'm quite pleased with that. It's just tightened up. Ideally I want to put maybe a spring washer under that, although I'm quite happy with the way that it is, because it's given me a nice close fit. And at the front of the vise there is no play at all, and it moves up and down okay on the part. In hindsight, what I might do, as you remember, I made this part, the inner shaft there just a little bit wider, so it sat tighter in the gate there. But I've got a little bit of play there. So if I move it up here, we can see that doesn't look quite so good. That does. This is how the part was made. In hindsight, what I might do, a project for a rainy day in the future, would be remake this part, but with the center hole that goes through off center. So what I could do was to turn this part and set the alignment with a close clearance, although bearing in mind we've got a painted finish there, so it's not going to get to a point where there's no play at all, because we need to allow for the part to ride over this surface, unless I machine that surface out. For what I need though, I think it's going to be okay. Most of my work is just parallel work, and one of the advantages of this particular vise is the fact that you can tighten up on a part that isn't even. This vise, like other vices I was quite surprised to find, is the fact that the bed had a rock on it, and also when I moved the slider up to this end, there was a high spot here, so we were around 0.2 of a millimeter thicker on this web at this end, which meant that as the slide moved up, it tightened up. So I did the old trick of mounting this surface here, the sliding surface, on parallels. Now this surface is in very good condition for an old vise, and this surface is the for me it's the controlling surface, because the jaws line up here. This jaw is actually a fixed jaw, it's cast in. This is the movable jaw, but you can't actually take them off, so I could skim a bit off here and then resurface these, but I don't really want to do that. So what I've done is I've taken this surface as it's in good condition, and I've inverted the part onto parallels on the milling machine. And first off, I machined this so that it was parallel, or the same thickness all the way along, which enabled this part to move up and down freely. And the other one, which was the surprise, was this plate on a large vise had quite a significant rock on it. So what I did is I took the 40mm end mill, and I skimmed the surface as part of the process. Now this has also been lapped as well. Here I've got a slight dip where we've not polished, but I think that is relatively minor, as we've got the clamping faces, the bulk of the vise round here is all supported, so that's a minor issue, that one, I think. So I'm going to live with it at that. Using the lapping table and lapping paste gives me quite a nice finish, but it is hard work, and I was using a fine paste on the lapping table and using a figure of 8 motion, just so that you try and keep the wear even on the lapping table. Also it'll end up with a dip in it, and everything you lap on it after that will have that pattern. So this is the vise now, and as I said, I'm more than happy now to put this one into service. And while I have the vise set up, I've got a smaller version of this one, which we have here. Now this went through the same process, although I didn't skim the gate in there, because this is, at the moment, it's a fixed gate. This is actually a cast part, so that is integral to the jaw. Now at a later stage, I expect what I might do is to machine that off and tap it and put in a part similar to its bigger brother, just so that I can adjust the play. That is quite a nice feature, but there's a significant amount of slop in that. I mean, I think that's, although it's still under a millimetre, it's still not ideal, so I would like to look at improving that at some point. Also, this part was very rusty, so I did a derust process on it, where I immerse it in white vinegar. Usually 24 hours is enough, and then you can just wire brush it to get rid of all the rust, or use some of this type of material. I mean, this bit's quite tired now because I've been working on these two vices, but this, usually combined with oil or something like WD-40, would be very good for cleaning up and dressing surfaces on machine tools. So the other thing I did with this one is these jaws, sometimes they're painted and a little bit unfinished, but I've done a bit of climb milling on this to give us that finish there, and take the paint off and clean the surfaces, as at this end as well. You can see that looks okay. This edge was clamped up, and I dressed that with a slipstone. I think it gets a better finish than a file would. So that's immersed in oil, and then I just carefully dressed that. So I've gone for a 45-degree bevel there, just so when you're moving parts around the vise that you can't cut yourself on it, because when you do a machine finish or a lap finish, you can end up with some very sharp corners that aren't great. The jaws have been cleaned, the base has been cleaned as well, and this has also had the skim on the bottom, because for a small vise I was quite surprised to see that this actually rocked a lot worse than its bigger brother. When you look at the finish on the bottom, it looks like it has been ground in some way at some point, but over time or through some other process, maybe post-process from machining this, something else happens on the vise that changes the shape or the geometry. But this one was quite poor, but it went through the same process. You can see we've got a nice even lap round, and I do like the dulled grey look that you get from using lapping paste on a lapping table. Again, it's a hard process, and I like to think that doing this just to, well, it's proof in the pudding that when you actually put it on the lapping table and lap it, that you get this nice continuity around here of this greyness, that you know that it's flat. And this is also confirmed by putting the part onto a bench of a drill onto the table, and both these vices now sit flat, which I'm really happy about. So these two guys are going to go into service now. One more thing to do would probably be to put a Tommy bar in these. I mean, this one looks like it's maybe a 3/8, and this one looks like a quarter. So we'll I'll maybe make those up and at another time, but I will show a still of this particular vise, because it came to me in quite poor condition, very rusty. But generally, providing a vise hasn't been drilled through at this point, then you can do quite a bit with it. These vices are easier because you haven't got the reference of this part in contact with that. Now, if that was actually captive and we needed to machine the surface for some reason, we then lose the alignment, and there's a little bit of movement in this thread. But what you'd find is that when the vise is fully closed, it's fine. When you want to do larger parts and you're out here, although you've got the same degree of play, up here it might be 1 or 2 millimeters. If it's baggy, by the time you get to this end, you're into fractions of a millimeter, and you haven't got the same latitude in the hole that sits at this end of the vise. To explain what I mean is, it's this type of vise where we can see we've got a hole, the part goes in, we've got a pin through there, and then when we withdraw the part, the screw, the jaw retracts as well. So with this vise, that's not something that we have. It's kind of manual, but it's not a bad thing to operate the vise, because the screw is very free, and I don't see that as being any particular hardship in the operation of these vices. It's quite quick to close. It's when you've got a very, very fine thread and you want to change to a large part or a small part that it could get a little bit tedious if you're doing multiple operations on a machine. So that concludes the vise overhaul.